Hello, everyone. Welcome to your weekly tech update, the show that explores the newest, coolest, and craziest side of tech available on the interwebs. I am your tech leader, Ray McNeil. Coming up on the program today, GTA 5 and GTA Online are coming to the PS5 on March 15th. Moonfall's filmmakers saved a NASA shuttle simulator and are now donating it to a museum. Happening in this week's What The chili cheesecake will definitely add a kick to any party. And of course, we'll wrap up the program with this week's Moment of Joy. All that and a whole lot more coming up on today's edition of your weekly tech update next. After suffering a delay last year, Rockstar Games has confirmed that GTA 5 and GTA Online will launch on the PlayStation 5 and Xbox Series X and S, of course, on March 15th. The move to more powerful hardware means some new bells and whistles for the best-selling game. GTA 5 and Online now boast resolutions up to 4K HDR and ray tracing, improved textures and draw distances, and up to 60 frames per second gameplay, something that it desperately needed. The PS5 version also features 3D audio and DualSense haptic feedback. The PS5 and Xbox Series X and S versions of GTA Online will launch as new standalone games. The PS5 versions will be free to players for the first 3 months, they say. GTA Online's improvements include the ability to skip the GTA 5 story mode prologue, a revamped tutorial, and the new Special Works Auto Shop. The new storefront lets players pick from a selection of vehicles designed to take advantage of the new hardware. First-time players get a head start by being funneled into the Career Builder, which gives them instant access to one of 4 businesses. You have your biker club, you can be an executive, a nightclub owner, or a gun runner. They'll be given startup cash to purchase a property, a high-end vehicle, and weapons so you don't feel left behind if this is your first foray into the GTA 5 online world. Existing players can take advantage of the Career Builder at any time by restarting their career as well. Fat chance that's gonna happen. If you're currently playing either game on the PS4 and Xbox One, you can transfer your GTA story progress and GTA Online progression to these new versions via a one-time migration when you launch it. The new-gen versions of GTA 5 and Online were originally slated for last November before getting delayed. Rockstar instead released the ill-fated Grand Theft Auto, the Trilogy, the Definitive Edition, and, didn't really go that well. Though a good idea on paper, the collection suffered from a litany of technical and presentation issues that Rockstar has spent the last few months trying to at least smooth over, including making the previous versions of each game available once again for purchase on the PC. Hopefully, these upgraded releases of GTA 5 and Online don't suffer a similar fate. No matter how good our human designs may be, evolution has had a 4 billion year head start, so there's no shame in copying off Mother Nature's homework. Engineers at the University of Bristol have done just that, and even improved on it, developing a tiny flying robot that flaps its wings more efficiently than an insect using a unique electrostatic zipping mechanism. Drones inspired by birds and insects have been flapping around for years now, like Harvard's RoboBee or the Delphi Nimble. But while they're capable of some nifty aerial maneuvers, they usually flap by way of complex transmission systems like gears and motors. The Bristol team's new drone uses an artificial muscle system that they call a liquid amplified zipping actuator, or LAZA, which requires no transmission of any kind. Each of the dragonfly-sized drone's wings is made up of an electrode sticking out from between two other smaller electrodes, at the base. A high voltage is then sent through each of the base electrodes in an alternating pattern, attracting the wing electrode to each one in turn. And do that fast enough and it produces a flapping motion, which is amplified by a liquid dielectric between the electrodes. With the LAZA, we apply electrostatic forces directly on the wing rather than through a complex, inefficient transmission system, said Tim Helps. He's the lead author of the study. This leads to better performance, simpler design, and will unlock a new class of low-cost, lightweight, flapping micro-air vehicles for future applications, like autonomous inspection of offshore wind turbines. The team says that the LAZA system lets users finely control the frequency and amplitude of the flapping wings and can provide more power than mammal or insect flight muscles of the same size. In tests, it was able to fly across a room at about 2.5 kilometers per hour or 18 body lengths per second. Its flapping wings lasted over 1 billion cycles with no drop in performance, demonstrating that it should be able to fly for very long distances. The team says that the LAZA system could eventually lead to smaller and more nimble drones that could be used in environmental monitoring, exploration, search and rescue, and even plant pollination. The research was published in the journal Science Robotics. Drones aren't anything new. Multi-rotor aircraft are becoming a bigger part of people's lives every day. From the latest batch of up-and-coming urban air mobility companies to hobby applications, electric aircrafts with 4 or more motors are commonplace, and generally they use conventional multi-bladed propellers to keep themselves aloft. That's not what's going on with this particular drone developed by engineering students at the University of Maryland, though. Assembled for a student design competition hosted by the Vertical Flight Society, it's a mixture of old and new, with rotors reminiscent of Leonardo da Vinci's aerial screw illustrations from the late 1490s. It flies like any other drone would, all while looking extremely bizarre and having interesting flight characteristics. The project started back in 2019, though a functional model wasn't built until 2021 by Austin Prett. He pieced together the drone with help from prior development work done by his team, which was sponsored appropriately by Leonardo Helicopters. Surprisingly, the design challenge was actually to build a modern aerial screw vehicle, so the students' basis for the design was more or less predetermined. After that competition, I continued on the research into making a flying aerial screw vehicle, Prett said. It was a fairly smooth transition from that. Prett's prototype uses conventional drone parts, minus the rotors, of course. They're built from a mixture of plastic, steel, and aluminum. The engineer tells The Drive that the primary disadvantage of these sorts of rotors is the weight of their construction. However, that doesn't mean they're without merit. Based on digital analysis, it's indicated that they produce a large portion of their lift, not necessarily by moving a high volume of air, but by creating a bound tip vortex. As a result, attempting to place a duct around this design would actually result in poorer performance, although Prett indicated that different screw designs could actually act in different ways. Other advantages include reduced downwash and potentially quieter operation, although it was made clear that a lot more testing would have to be done with this sort of rotor to get any definitive performance data. Prett said he's not in a position to continue developing the concept as he's taken a job in the industry. That said, he's open to seeing others advance the idea.